Hi, everyone. Thanks for coming along for a very packed seminar for Hannah. I'm Hannah also, and I'm the host for the seminar this morning. And our speaker today is Hannah Wauchope. She's a research fellow at the University of Exeter, and she did her PhD at the University of Cambridge and her honours here at CBCS with Rich Fuller. And today she's going to talk a little bit about the work she did for her PhD in protected areas. So I will pass over to Hannah. Thanks, Hannah. Actually, get it out of the way.
Okay, Zoom people, please say if that mic is no good. Do we have, hang on. Can you see my mouse on the Zoom screen if I use that as a pointer? Okay, I can't make it do something pretty, so it'll just be a mess. Cool. Welcome, everybody. So my name's Hannah, and today I'm going to be talking about some work that I've done with the team listed here, looking at whether protected areas work. And along the way, we learned a lot about doing impact evaluation, so I figured I would tell a bit of a tale about how that all went. So I don't really need to tell the people in this room that protected areas are one of the kind of key cornerstone tools that we use in conservation to protect biodiversity. This is probably a little bit old now, but the green is where protected areas are currently in the world. In 2010, the UN Convention on Biological Diversity set a target that we wanted to protect 17% of the Earth's land and sea by 2020. And we've pretty much met that target, not quite, but close to. And there are now big discussions for the next decade's worth of targets to be what people are terming 30 by 30. That is, we want to protect 30% of the Earth's surface by the year 2030. And it's looking likely that that is going to be ratified as an agreement later on this year. That's all well and good, but a target such as 30 by 30 hinges on the assumption that protected areas actually do their job. So it's really important that we know that and we know how effective they are before we go designating a whole bunch more of them. And so that was the question me and my team set out to answer. Today, I'm going to talk you through the journey of us trying to answer that question, from formulating the question to the pre-analysis plan that we wrote before we began doing the analysis, to a bunch of stuff we learned about doing impact evaluation, especially when you're working with time series data, as we were. And then finally, I'll give you some results at the end. So hang on, I'm going to get that out of the way until I need it. First of all, the question, do protected areas work? And I've been a little bit cheeky in using that as my talk title, because obviously I don't think anybody could fully answer this question, even with a lifetime of research. And there are many ways you could come at the question. And I found this really great paper just last week, actually. It came out earlier this year. And it sets up a really nice framework for the ways in which we can think about how protected areas have impact and how we can assess that impact. They set out 3 ways that we think protected areas can have an impact and that we should assess them. That is on their ecological outcomes, their social outcomes, and their social ecological interactions. I'm an ecologist by background, and my research and this talk only focuses on the ecological outcomes of protected areas. And so it's really important to say front up that it's important when we think about protected areas as a whole that we're thinking about all these things, not just the ecological outcomes. People who are much cleverer than me can talk about the other ones. And even within ecological outcomes, I think there's kind of 2 ways that we can think about the impact that protected areas have. The first one of them is how well protected areas prevent habitat loss. And there's been quite a lot of really great research done already on the impact that protected areas have in this regard. I'm going to flick through some papers fairly quickly here, refer to the video if you want to go and actually find the references. So there's been a bunch of papers, from, I say quite a while ago, that wasn't that long ago, 10 years ago, and more recently that have looked at how well protected areas both prevent habitat loss and things like stop anthropogenic pressures. And some of these studies have been really robust, like this one. And the general vibe is that, yes, protected areas are doing a decent job at preventing habitat loss. But habitat's only one aspect. How well a protected area is actually supporting the populations that live inside them. You know, we could have a protected area that stops deforestation, but there's no animals left in the forest. And the studies that have looked at this, there's been a number of them, but they have all been a little bit restricted in their experimental design. And I'll explain what I mean by that in a second. But that's meant that none of them have been able to really get at this question in a really robust way. And I should say that's mostly because of a lack of data, not because the people doing those studies were being idiots or something. Yeah. Sorry, Tatia. Yeah, so what I mean by they were suffering in their experimental design, I will explain now. So in order to understand the impact of anything, but in this case for a protected area, we need to understand what would have happened in its absence. And the ideal way to do this is to take your Earth, where you have a space that you're going to protect, clone it, have a second Earth, protect one of the Earths, and then have the other Earth identically, and then observe the two through time. Obviously, that's impossible. So we instead need to find ways experimentally to infer what would have happened on the ground. And there's two main ways that we do this. The first is to use a before-after study design. So let's imagine that we have a population of lions. Oh, I should use my clicker rather than pointing at the screen. Okay, a population of lions. And let's say we're looking at them through time and they're declining through time until we designate a protected area, and then the lion population starts increasing again. We would look at this and go, excellent, the protected area has had a positive impact, because we assume that in the absence of this protected area, the lion population would have kept declining in this period. So that's the before-after study design. The other one we can use is a control intervention study design. And this is where we only look at the years after the protected area has been designated, but we compare our protected lion population to an unprotected lion population and go, okay, the unprotected lions aren't doing so well, the protected lions are awesome, the protected area seems to be doing its job. And almost every study on protected area impact on populations thus far has used one of these study designs, but they both have limitations. So in the instance of before-after, by not considering what was happening to an unprotected population, we could be completely missing the picture. So for instance, maybe there was an unprotected population of lions that showed the exact same trends through time. Turns out this flip from a decline to an increase had nothing to do with the protected area. Maybe it was a climate thing. Maybe there was a policy change about hunting. Who knows? But whatever it was, clearly it wasn't the protected area that instigated this change. We've made the wrong conclusion. Similarly, with a control intervention study design, by not considering what was happening before the protected area was designated, we might be missing out on the fact that, say, this protected lion population was already increasing before we ever put a protected area in. So it wasn't the protected area that has given it that positive effect, it was just already happening anyway. To get around this, the kind of gold standard in how you should do an experimental study, or sorry, an experimental design, is to smash them together and do a before-after control intervention study, in which you compare outcomes from before to after between your control and your intervention populations. So that's what we set out to do. We had access to this absolutely amazing data set of water bird population counts with data taken from Wetlands International for most of the world, and then the Audubon Christmas bird count for North America. Big shout out to Tatsuya, who was my supervisor in Cambridge and then bizarrely came to UQ, we swapped places, who initially collated this data set. And at each of these sites that you can see, we had counts of bird populations through time at those sites for up to 40 years. So really, really high quality data through time for hundreds of species at thousands of both protected and unprotected sites. Before we began, we decided to do something called a pre-analysis plan. And this is basically what it says in the name. Pre-doing your analysis, you write a plan. These are really popular in medical science, the psychological science. What am I trying to say? Psychology. And basically, and there's been a call recently for pre-analysis plans to become more standardized in ecology and conservation. And the idea of a pre-analysis plan is that it helps to prevent questionable research practices. I'm not going to go into great detail about these, but basically the idea is that when you're doing a study and analyzing data, it is quite easy to like try a bunch of different stats techniques, see where you find some significance, play around a bit, and particularly when you're doing analysis of big data sets, kind of find the result that you want to find just by fiddling around. And even subconsciously, you can do that. Even if you've got the best intentions, you're trying really hard to like do the right thing and not mess around with your data, it's quite hard to, we're all humans, it's quite hard to actually stay unbiased. And so pre-analysis plans have been sort of put forward as a way to address this. You set out before you begin exactly what you're going to do, and then you hold yourself accountable to it so that you can't do anything wrong. We thought, great, we wrote one, took me ages, I was really proud of myself, published it on PeerJ. And we decided that what we were going to do was at each of our protected sites that you can see in green, we were going to do a Backy analysis and look at the difference between a protected and unprotected population before and after. I made this really nice schematic of how I was going to do the impact evaluation, how we were going to analyze the data. I'm not going to bother to explain it because it was wrong. And as soon as I actually started to try and do my study, I realized that this beautiful thing that we had spent weeks discussing and thinking over just did not come close to address all the issues that we faced when we actually tried to analyze the data. Which has led me to reflect a lot on pre-analysis plans and whether it was worth those many months that I spent thinking through and writing something that then just had to go out the window. And as I then started reading about this and thinking about it, I found a bunch of papers that have kind of questioned whether questionable research practices are actually as big a problem as we think. I don't have time to go into it now. If you're interested, refer to the video. There's a bunch of sources here. I'm not convinced that it's as big an issue as we think, unless you're someone that's actually really trying to be naughty and play around with your data. And even if we still need to address questionable research practices, I think particularly in ecology and conservation, I would not personally would not recommend a pre-analysis plan. I should say, I think some of my co-authors would disagree with me on that. So that's very much a personal opinion. I think it took too much time and I don't think it actually helped in any way anyway. So that was that. Have a read if you're interested. So the plan that we'd set up was wrong. And we'd based that on sort of the present day literature about how to do impact evaluation with time series, blah, 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 which left us in the space of going, well, what do we do now? How do we evaluate impact when we have time series data? And as I started to look into this, I realized that present kind of frameworks that we have in ecology really don't cut the mustard when it comes to how we should be doing this. And I looked into how the methodology that other fields use and found that there's a lot that we're missing. We ended up writing a whole paper purely about this. So I'm now going to take a detour away from protected areas for a second to just talk about impact evaluation and the framework that we came up with. So let's forget about water birds. I picked elephants as a random example, mostly because this picture was cute. I'm going to explain what I mean when I say that previous methods haven't been so great for how we can evaluate impact with time series data. And I've chosen elephants because this can apply to anything. It doesn't have to be protected areas. I'm just going to move that up a bit. So let's say we have a population of elephants and we want to know whether a hunting ban that's been introduced has had a positive impact on the elephant population. What we would normally do in ecology is look at the average count of elephants in the years before the hunting ban and the average count of elephants in the years after the hunting ban. In this example, we would conclude that there's been a negative impact from the hunting ban, which is unfortunate. There's less elephants when we instigated a ban, not what we want. Okay, well, maybe this is just because we've used a before after study design. Maybe there's another population of elephants that didn't have a hunting ban that's declined even more, so we can at least say there's been a bit of an impact. If we look at the control population in this example, maybe they haven't even declined as much as the population that did have a hunting ban. In standard frameworks, the difference between this intervention and control before after difference is called the Backy contrast. And in this case, it's negative. So that's pretty conclusive evidence that this hunting ban has had a negative impact on our elephant population. We would say, oh, the hunting ban has had unintended consequences. It's caused a drop in the number of elephants. We'd maybe make some policy decisions, stop instigating hunting bans, lift the hunting ban that's currently in place, and start investing a bunch of money in new ways that we can think about how to protect these elephants. But we've not actually analyzed that data correctly, because when we're looking at count data that goes through time, we should not be looking at averages. Let's actually look at the counts that have populated this, these averages. And so the averages were taken, truthfully, from those counts. But if we instead look at the trends of those counts, we find that the elephants were declining before the hunting ban was introduced and have started increasing again after the hunting ban was introduced. That's a completely opposite conclusion. Now we go, fantastic, the ban is having a really positive impact. And maybe from that control population, we see that actually that's just been consistently declining because it hasn't had a ban introduced. Suddenly our Backy contrast is positive, and we conclude that the hunting ban has reversed the decline in the number of elephants. Amazing, maybe we start bringing in more hunting bans in other places. And now I should say, like, obviously, in this example, if you were actually the person analyzing this data, you probably would have spotted that the averages wasn't the way to go and dealt with this anyway. And I think that, which is, I suspect, why this problem hasn't been addressed in ecology before now, because it's only been recently that we've had access to big data sets. But if you're doing an analysis where you're looking at hundreds, in my case, thousands of populations, and just trying to establish some sort of analytical framework, we could have looked at averages and never stopped to consider individual sites and what was going on. And then we'd be making completely the wrong conclusions. So basically, if your data set is showing trends through time and you want to evaluate impact, you have to compare the trends and not the averages of what's going on in that data set. And this applies not just to hunting bans or protected areas, it can apply to anything that you're trying to evaluate impact for. That might be oil spills, policy changes, introductions, whatever you like. And it doesn't just have to be on counts of populations. You could be looking at changes in body size through time, or like changes in number of offspring through time. This idea of analyzing trend change in ecology is super recent. To my knowledge, when I wrote this paper, at least there'd only been three papers that had looked at it. And I should say I'm very grateful to Mathieu Chevalier's work in these last two, because we based a lot of our framework off the sort of foundational work that that team had done. If you're looking at trend change, there's a final thing you need to consider, which is immediate change. And this is particularly important in ecology because we often have really noisy data. We might have a trend change that looks like this, but we could also equally have our data points doing this, doing this. And so then suddenly you've got both a change in trend that's positive, and you might have an immediate change that's negative or positive. And so we also need to consider this. This starts getting very confusing. So I made a decision tree. How do I evaluate impact if I have a time series data set? First thing you should do is ask yourself the question, does the thing you're measuring experience trends through time? Because there are examples where it doesn't. For example, if you're looking at rates of deforestation, we don't generally expect that to show consistent linear trends through time. It's going to vary year by year, depending on a ton of sociological factors. In that case, using the old school framework is fine. You can compare average change. If the thing you're measuring does experience trends through time, then you need to ask yourself a secondary question. And that is, do you expect a gradual or an abrupt response to your intervention? If you're expecting a gradual change, like the recovery of a population after you're doing some habitat restoration, you can just look at trend change because you expect these lines to join up. But if you're expecting abrupt change, maybe a mass fatality post-fire, or in our case, the waterbird population counts we were analyzing, waterbirds are super mobile, and you can have 1 year where there's 2 birds at a site, and the next year 1,000 flock in, so you can see really big changes year to year. Then you need to consider both trend and immediate change. There is more. This is only one of the more. There's more in the paper, and I'm going to stop after this. What happens if trend and immediate change disagree? So for instance, maybe we have this population of birds, and we've seen a positive trend change. Protected population's gone up, unprotected population's gone down. But a negative immediate change in that at the point where we designated the protected area, there was a drop in the protected population and an increase in the unprotected population. What do you do with that? Again, if you're analyzing one site, you probably just talk about it, think about what might have been going on there. But if you're doing a big analysis with many sites, you need to make some decisions. The fairly inelegant solution we've come up with oh, sorry, if you're doing a big data set, we need to take lots of positions. The fairly inelegant solution that we've come up with, which I would love for someone to come up with a better solution, so if anybody has any ideas, please say, is to think through all of the different ways that your population could be affected by the impact and then categorize them. So in our case, this is specific to our protected area case, we decided that a positive trend or a positive immediate change, if we observed either of them, we would say, okay, the protected areas had some sort of positive impact, and we would lump that in a positive impact class. Then we thought about ways in which we might expect no impact, or ways in which we might expect a negative impact. You'll see there's a term called all zeros in this. I'm not going to go into it in the interest of not boring you to death, but it's in the paper if you want to go and read more. Question? Yeah, absolutely. So if you look at the formula that we have in the paper, you could, sorry, good point. Instantly forgot that. So the question was, can you look at the magnitude of your trend and immediate change to see whether one outweighs the other? And the answer is you definitely can. In the paper, we have the formula to calculate the trend and immediate change, and you can get estimates of the magnitude of each. But at the end of the day, it's still going to be a sort of judgment call that you're making as to, you know, if one outweighs the other slightly, is that enough to decide that it wins, or does it need to outweigh it largely? And so you'd probably still need to end up at some point making a judgment call and having some categories about what that is. So there may be, I mean, there may be something to think about there about a way of making that more rigorous, which is worth thinking about. It's a good idea. Yeah, so yeah, that's worth following. This, I don't love this solution, but it's the best we could come up with. Yeah, basically to summarize, it's really complicated. Go read the paper. If you're interested, I hope that what we've written in this paper is a fairly good breakdown of everything you need to think about if you're doing an impact evaluation with time series. And we talk through all the complexities and the ways in which you can hopefully frame that to help you not get too lost. Right. This talk was meant to be about protected areas. So after we spent maybe a year in purgatory figuring all of that out, we finally came to a place where we had our framework set up and we could start to look at the question that we'd set off with in the beginning, which was, do protected areas work and have a positive impact on populations? We returned to our waterbird data set and we asked 3 questions. First of all, given all this stuff we just learned about impact evaluation, and given that almost every study so far looking at populations has used either a before, after, or a control and intervention rather than a BACI study design, we wanted to know how much do before, after, and control intervention study designs cause misleading conclusions? How often do they get it wrong? Next, the money question. What is the impact of protected areas on populations? And finally, we wanted to know what factors contribute to protected area success. So to answer this, for each of our protected sites that you can see in green, we analyzed the impact of protected areas on each population within that site using a before, after, a control intervention, and a BACI framework. Obviously, for control intervention and BACI, we then need to pair our green site to a purple site that's unprotected. We went through a really rigorous matching procedure to do this, where we basically wanted to make sure that our protected and unprotected populations were as similar in every possible way, except for the fact that one was protected and one wasn't. And unfortunately, what this meant is that we hemorrhaged sites. We lost a lot of them, and we decided this was worthwhile because if you're comparing sites that aren't similar, then it's useless. You really can't be saying anything about what the impact of the protected area has been. We still ended up with 27,000 populations across 1,500 protected areas. But as you can see, our data set is now very heavily biased towards Europe and North America and away from the global South. And it's really important to remember that for the rest of these results, that these are biased results and that we really need to do more studies in these regions and in Australia and New Zealand to get an idea in the rest of the world. So we then, for our before, after control intervention and BACI, did a beefed up version of the framework I just talked about before, where we categorized all the ways that a protected area could have impact as either negative, shown in red, no impact, shown in the yellow/gray, or a positive impact, shown in blue. It's not really important what's within those categories, but it is important that red is negative, these colors are no impact, and blue is a positive impact. Now, first question was, how much do before, after, and control intervention study designs cause misleading conclusions? So what we're looking at here is for before, after populations. This is the proportion of populations that were either positively impacted, not impacted, or were negatively impacted. When we reanalyze these populations under a Bakke framework, we found that 37% of populations changed in our estimate of the impact of protection when we analyzed them more correctly under a Bakke framework. Particularly, you can see over half of what we thought were negatively impacted populations actually turned out to have been not impacted or even positively impacted by protection when we analyzed them correctly. More alarmingly, the control intervention framework, which I would argue is the more common one that's been used thus far, fully 50% of populations had a different impact from protection when we analyzed them correctly. And this is kind of scary, given that our whole understanding of the impact of protected areas on populations thus far has used one of these two study designs. Given that, what is the impact of protected areas on water birds in a biased data set towards Europe and North America? So what I'm going to show you here is a ton of columns, and each one represents a protected area. And then the colors within each column is going to represent the proportion of populations in that protected area that were negatively, not, or positively impacted by protection. Now, obviously, we're all hoping that this graph is basically just blue. Like, we want to know the protected area is having a really big positive impact. And unfortunately, that's really not what we see. Yeah, not a great deal of blue, and an awful lot of yellow and grays, and way more red than we would hope. In fact, only 27% of populations showed a positive impact from protection, and 21% were negatively impacted by protection. The vast majority of populations, however, we just couldn't detect anything, no impact from the protected area. Now, it's important to say here that most of those no impact populations, so 41% of populations overall, were no impact, but these kind of more neutral tones mean that there was no impact, but the population was still stable or even increasing in the protected area. It was just not doing any better than an unprotected population in the same period. And so that means that the majority of our waterbird populations are either positively impacted or they're doing okay in the protected area. So it's not completely bad news, but we would still have hope for a much stronger signal of the positive impact of protected areas here. It's important that I pause here and remind us what I discussed at the beginning of the talk, and that is that there are a bunch of papers using robust, well, maybe not a bunch, but a few papers using a really robust Bakke study design that do show that protected areas are effective at preventing habitat loss. And also what we consider here doesn't take into account things like future threats. So a population might show no impact from protection now, but it might be positively impacted in the future. So the take home from that previous slide is not protected areas are useless, throw them in the bin. It's just that they're not doing as well as we would hope that they are doing. And that leads us to our final question. Well, okay, protected areas aren't doing nearly as well as we'd like. So what factors do contribute to the success of a protected area? We ran a pretty simple correlation where we correlated impact with a bunch of site and species characteristics that might predict when impact is more positive. And this included things like the size of the protected area, whether it was managed for water birds, the governance in the country the protected area was located in, the size of the species, whether it was a migrant, how close the site was to humans, and also just the taxonomic order of the species. You'll notice on the x-axis that it says number of analyses. This is because actually everything that I've shown you so far, we ran 21 times, varying a bunch of parameters to make sure that our results weren't sensitive to any kind of specific analytical decisions that we'd made. And to look at this, we decided that we would look across all of our 21 analyses and see how often we detected significant correlations between these things and protected area impact. What you're seeing here, red means that there was a significant negative correlation between the predictor and impact. Yellow is insignificant negative. This kind of blue-gray is insignificant positive. Dark blue is a significant positive correlation. So you can see that for almost every predictor, it's kind of a wash. There's not really any significance. There's a mix of positive and negative. It's a bit blah. However, for protected area size and management for water birds, we see that across all well, very nearly all of our analyses, there was a positive correlation. And particularly for waterbird management, most of our analyses showed a significantly positive correlation, less so for protected area size. What we take from this is that there is a positive signal that if you manage a site for waterbirds, it's more likely to have a positive impact. And there is some indication that bigger protected areas are more likely to have a positive impact than smaller protected areas. So what does all this mean? First of all, it means that protected areas are not generally having a positive impact on waterbirds. But higher quality areas do improve outcomes. And to me, what this says is that CBD targets need to be having a much bigger emphasis on the quality, not just the quantity of protected areas. If we keep on with this really insistent drive to create more and more protected areas, we'll be spreading our resources even thinner in order to manage them appropriately, when clearly we actually need to be investing more in managing the areas we currently have. I'm not saying we shouldn't designate any more protected areas, and I still don't know what I think about the 30 by 30 target really, but I do think that it runs the risk of us just putting way too much emphasis on just protecting more and more land without any of that land being managed well enough to actually positively impact what we're trying to protect. More generally, the conclusions from this talk are that you should ask questions in good faith and stay as unbiased as possible. You should read a lot if you're doing impact evaluation about how to do that, but I'm not convinced that pre-analysis plans are the answer. Again, my co-authors might disagree with me there. If you're evaluating impact with time series, you need to compare trends, not averages. And we need to focus a lot more on protected area quality. And I need to thank the team. This is very much not a solo effort. Thank you so much to my entire team, Julia, Tatsuya, Bill, Tej, Rich, Daniel, Sabosh, Ali, Jonas, Benno, and Tom, and also to various funders and our data providers, particularly Wetlands International and Audubon. Thanks, everybody. Louis just, I'll cover his full question in a sec, but he's asked what time. Totally. Okay, so Louis just asked about bias in the data set. So we know that it's spatially biased, but Louis also pointed out that obviously it's taxonomically biased. We were only looking at water birds, which is a subset of birds, which is then a subset of all life. And he asked how temporally biased the data set was. And the answer to the last bit about how temporally biased it was is kind of medium. We went back to, I think the 70s is the earliest that we have protected areas designated. So obviously we can't consider the impact of, I don't know, say really old protected, like Yellowstone in America or something, because that was designated well before we were consistently counting birds there. Unfortunately, that temporal bias is something we can never do anything about because we can't go back in time. Read the taxonomic bias. Yes, it's definitely an issue. Obviously, we don't know what any of these results mean for mammals or reptiles or anything like that. We reckon, well, we would have hoped that water birds would actually show more, on the whole, more positive responses to protection than, say, another taxonomic group. And the reason for that is that water birds can adjust really quickly to site conditions. So let's say you had a site that was quite poor, but then it became a protected area, it was restored, it started doing a lot better. Birds can flock in very quickly. And so you would hope that we would much more quickly see a positive signal from that protected area versus, say, a slow breeding mammal or something where you'd need a lot of time to start seeing the impact of any positive interventions. And similarly, if there was a site that was doing poorly, the birds can just bail. And so you'd hope to see them. Anyway, so we had hoped that given that, this would have been a conservative estimate where we would have hoped for even more positive than otherwise, which is clearly not what we saw. But I wouldn't stretch that to then say, I think mammals and reptiles and other birds would be doing even worse than water birds are. I don't know. In terms of plans to do more analyses, we have done some more analyses with another data set. I don't know how at liberty I am to share that publicly, so I will stop there, but yes. But it's a struggle as well, because obviously birds are much more well counted than other taxonomic groups. So we're much more limited in, say, data on mammals or reptiles, but we're doing our best to try and, yes, do some more analyses there. Mm-hmm. That's a great question. That sounds like a question that I've like set up a friend to ask. Yes, we did look exactly at that. So the question was, did we consider the time frame over which we do the Backy analysis? So for instance, does it make a difference if we look from just 5 years before to 5 years after versus 20 years before to 20 years after? That was something we were very concerned about. So those 21 analyses I mentioned earlier, we varied a few parameters in them, but one of the biggest ones we varied was how many years before to after we looked. So in the main analysis that I showed you, this is with 10 years before and 10 years after, so 20 years all up of surveying. But we looked up to 30 years before and 30, no, that's not right, 15 years before and 15 years after, so 30 years of surveying, and down to just 5 years before and 5 years after, so 10 years of surveying. We couldn't go beyond 30 on the upper level, just because of data restrictions, and we didn't go below 5 because of some previous research that I'd done showing that it's kind of pointless at that point. We couldn't find any major differences when you vary that time scale. Like, it still roughly came out. I mean, obviously, you know, the values weren't exactly the same, but qualitatively the results were pretty similar. I'd be interested to look at that with other data sets not looking at protected area impact, but at least in our case, yeah, we didn't find much change. Follow up? Louis' follow-up question there was, okay, so if we didn't really find much difference between monitoring for 5 years versus 15 years, can we just stop after 5 years and say that's good enough and not have to bother investing more? The previous research that I just mentioned actually was trying to answer that exact question. We were looking at how likely you are to detect trends in the population depending on how long you monitor them for. And we found that if you do find a significant, in our case, we were just looking to see whether you detect a positive or negative trend, but I would cautiously say that you could probably apply it here as well. We found that if you do detect a significant trend, so either, you know, the population is significantly increasing or declining after a few years, that's almost definitely going to hold, even if you monitor for a much longer time. But if you've only monitored for a few years and you don't detect any significant trend, there's a chance that if you monitor for longer, you will end up detecting a significant trend. So it's kind of like, if you find a strong signal of something, you can probably be like, great, that's fairly trustworthy. But if you don't find a strong signal, you can't go, yay, there's no signal, because it might be that if you monitor for longer, you'll detect one in the end, which actually is kind of intuitive if you think about how significance works. But yeah. Yeah, go for it. Yeah, that's a great question. So the question was, if it's difficult to get data on actual counts of populations through time to expand, you know, to look at more taxonomic groups, could we instead look at metrics like species richness and see whether there's been more or less species present at a site before or after a protected area? Yes, that's a great idea. There have been some more studies that have looked at the impacts of protected areas on species richness. I think I think a couple of them have been Backy studies, but I'm now not entirely, can't remember. There's one on mammals in Europe. That's vague. See if you can find it. But yeah, no, you definitely could. That would be really interesting to look at. Yeah. Again, but that still hinges on someone having visited a site year by year and counted what they can see. And often if people are doing that, they're going to be counting the actual population numbers as well as just what's there. But it's still worth thinking about, and definitely could, yeah, expand what data we have available. Mm-hmm. So Jonathan's question was, oh, do I need to repeat it given it was on Zoom? Jonathan's question, yeah. Yeah, so could we start seeing more cohesive metrics that measured like protected area quality and how well they're affecting populations? I would love that. Hopefully, yes. That we talk about that in our paper, and I like in an ideal world, yes, I think that targets should absolutely include rigorous quantitative measures of how the protected area is having an impact, and not just on these ecological outcomes. Like I also mentioned at the start of the talk, we also need to think, and I should have said this in my conclusion, I forgot, we also need to think about the social impacts of protected areas. And I think that's something that we possibly don't, including me, don't think enough about in the sort of ecology conservation world. About, you know, we talk about something like 30 by 30, and we don't think about that there might be people living on the land that we want to protect in those areas, and what are the impacts of that going to be, and is that okay? And I think that we need to be thinking a lot more about all of these sorts of things when we're setting targets, and having things that we can measure. Because the thing is, the Aichi targets from 2010 did mention things like protected area quality, but because there's no like really robust target that people can, I mean, this is my theory, there wasn't any quantitative metric. It was just like, they should be high quality, which is very easy to just be like, yay, we did it, they're high quality, but without having something that you can measure and actually, you know, set a target on that for, it's much easier for people to not do the thing. So yeah, basically, yes, I hope. Sure. Oh, I'll go you next. Yeah. Sure. So Misha's asked how we accounted for factors external to the fact that the site was protected. So I'm guessing Misha's thinking things like climate change or, I don't know, human impact on the site other than protection. So the way that we try and iron that out is through the matching procedure. I've got some slides on it, it's probably not worth going through them. Basically, the way are protected and unprotected sites is that those sites had to be really similar in their climate and in their current human impact, and in a bunch of other things that I now can't remember but are in the paper. But basically, by ensuring that the two sites you're comparing are super similar, and also they had to be geographically fairly close together. That means that something like, say, if the climate changes, the climate should be changing in the same way at both the protected and unprotected sites, which means that then when you do your Backy analysis, that, because they're changing in the same way, that kind of just disappears. And then if you're observing any difference, the difference is from the protected area rather than from the climate, because they experienced it in the same way. I didn't explain that super well, but hopefully that made sense. You had a question?
Yeah, it follows right on that. Properly. First of all, just beautiful. Right.
Thanks.
You really went through it the right way. I also appreciate the color scheme.
I spent way too long on that, so I really appreciate that. Thank you. Thanks.
So we were doing something similar, playing around and looking at the protected areas for mammal things. What we found is it was really hard to compare. It's like a bigger protected area, but how much spillover. And then so our period study, it looked like it was also, this whole site was increasing. Was the protected area working, or we didn't really know. Like, so we kind of ran into a wall there.
Yeah.
And so there's this trade-off between how far away we go. And with a bird, I would assume bird.
damn it. No, so we considered that. So the question was, how did we consider spillover effects from the protected area when matching? So if you have a protected site here and an unprotected site here, maybe it looks like the unprotected site's doing well, but that's just because this site's doing so well that populations are flowing into the unprotected site. But then obviously you also can't make the unprotected site so far away that it's now completely different from the protected site. It's a tricky one. We got around that by sensitivity testing, basically. So within those 21 analyses, we also varied both the max distance away a site could be and how close it could be. We never allowed them to be super, super close, but we varied the extent to which they could be a bit far away and didn't really find any differences. It would be really interesting to just analyze that on its, so in those 21 analyses, because we had so many things we wanted to sensitivity test, we did something called Latin Hypercube sampling, which is basically where you have all these parameters and then you sample, I'm not going to explain this well at all, sample all of the different ones in kind of n-dimensional space, which is a really good way of sensitivity testing, but it's not a great way of looking specifically at individual factors. So it'd be really interesting to just do a study on spillover effects. I think we were really helped though generally by just the quantity of data we had. There were so many sites that meant that we could match quite well. This other analysis that I'm mysteriously alluding to, we have been really struggling because it's not with birds where we have tons and tons of data. It's really, really hard to find, yeah, good matches. Yeah.
Thank you, great talk. I was wondering, so with the time series analysis you presented, you have it's quite sensitive to how you decide which time the intervention. So suppose we have a protected area. It could be that once so all the interventions happen after the actual intervention time or before, let's say, the government announces, well, I'm going to designate protected area in X days, and then the hunters will go away eventually. So there's got to be a time lag or difference between when the interventions are going to be actually and when the protected areas actually. Have you looked at whether it's possible to correlate intervention actions directly to the effectiveness of populations?
That's a really, really good question. So the question was, when a protected area is designated, that doesn't necessarily mean that all the intervention actions are going to happen at that time. It might be that it's not 5 years until someone starts doing something to, improve the habitat, or maybe the intervention happened before the protected area was designated, and then it was designated off the back of that. That's something we really wrestled with. So we did some preliminary analyses where we varied when we set the kind of date where we looked from before to after, to see whether, maybe you should be looking at sort of 3 years post designation before you start expecting to see a positive increase. We couldn't find any signal there. And I would hope that in our analysis, because, in the main one, we were looking for 10 years before and after, and then even longer in some of our sensitivities, even if, so let's say you set your protected area date there, the population was declining and then starts increasing here like a few years later, that should still show up in the models. It wouldn't be as strong a signal, but it would still show up. I agree, it would be really interesting to actually do an analysis where you found out when management actions had happened and then really tightly look at your analyses just then. There's just no way on the scale that we're looking at that you could do that. And I'm working with a master's student at the moment who's looking just in the UK, not even the UK, just in England, at trying to look at actual management actions and how that correlates these impacts. But even she is struggling to get any estimates of actual dates of when things on the ground happen. So it's the kind of thing that you probably have to do at one or a handful of sites that you know really well. But if someone is working in a protected area that has access to that information, that would be super interesting. Yeah. No, good idea, Matt. So Matt's question was, did we look at the cases where positive and where trend change and immediate change disagreed, and did we penalize the break parameter? No, we didn't. We should have done. That's a really good thought about the penalization. I did look at some of the cases where they disagreed, though. Really hard to know without having, like, I was joking about this at morning tea. Like, I would class myself more as a data scientist than like someone that knows a lot about birds. And I'm looking at the data of a site from the west coast of America, and I just have no idea why there might be a difference between the trend and immediate change. It's another thing that if you had a better knowledge of a few sites, it would be really, really, really interesting to look at why that might happen. Some of the theories we came up with was that maybe if a protected area was initially designated and they had to do a bunch of messing around, like if it was a really degraded site and you had to really muck with it in order to put it into a better space, maybe initially there would be a drop in birds because they all go, whoa, when there's a bunch of people there mucking around restoring the habitat. But once it's been done, they flock back as it improves. And so then you might see an initial drop and then an increase, maybe. I don't know, it'd be interesting to look into that more. Okay. Okay.
I agree absolutely that you comment on quality as well as quantity.
Mm-hmm. Do I need to repeat that? Okay, this is Mark and Misha's questions. They've had a little chat in the chat, so anybody watching in the video. Oh, wait, but the chat doesn't come up on the video, does it? Okay, I'll summarize briefly. So the discussion was about basically, yes, we need more metrics of quality. How on earth do we measure that easily? Do I have any thoughts? Yes, it's a huge question, because obviously, ideally, we'd now visit every protected area and count everything that's in it and get metrics for that. That would be a huge amount of investment. It's not really realistic to suggest that. The UNWDPA, so the World Database on Protected Areas, there's too many acronyms, UNEP-WCMC's WDPA, which is the World Database on Protected Areas, have established something called the Management Effectiveness Tracking Tool, where they have a survey that goes out to site managers, asks a bunch of questions about both how they're managing the site and how the site is doing. That I think is really promising. It's being rolled out currently. It's good in the general sense, in that it's mostly being rolled out at the moment in the global south. Bad for this analysis because it meant that there was no overlap between the sites almost no overlap between the sites that we studied and sites where that management data is available. That would have been fascinating to have that much more high quality management data to correlate to our results. But I think things like that are a really good start as a metric. And if that can be rolled out across more protected areas worldwide, that is at least the beginning of a way that we could be looking at quality, because it's a standardized survey with standardized responses. So that'd be really interesting. And I'd love to, I'm kind of biding my time for when there's more data available from that to do some analyses. It'd be really interesting. Otherwise, I'm all ears for ideas to monitor in a way that you could set metrics. It's a really tricky question. So that, yeah, kind of a comment as well of the fact that measuring social governance quality could be a good way of understanding the social impact of protected area success. yeah, I think that management effectiveness tracking tool is trying to sort of cover not just the ecological outcomes, but the sociological outcomes as well, which is, yeah, really, really important. Yeah, agreed. I think that's probably.
Thank you.